So, hello everyone. So, we are at the end of the conference and the last talk for the day. So, our next speaker is Talia Nassi, and she'll be talking about controlled rollout with React Native and feature flag. So, Talia Nassi is an international keynote speaker who delivers content, especially she talks about testing and quality. She's a developer advocate at Split.io, where she works closely with engineering teams and globally helps them to ship software more efficiently. She's passionate about feature flagging and canary launches. I'm really excited about this talk. And yes, she's spoken at countless conferences internationally. And welcome, Talia. How are you doing?
Thank you. Thank you for having me. I'm doing good. How are you?
I'm good. Are you excited for the talk?
I am. This is one of my favorite talks, so it'll be good.
Then over to you.
Great. Okay. So we're going to talk about controlled rollout with React Native and feature flags. And this talk is kind of about React Native and mobile. So we're going to get through some of the specific mobile topics with iOS and Android. So let's begin. So I'm Talia. I'm a developer advocate at Split. This is my Twitter and my contact info in case you guys have questions after my talk. So I want to introduce you all to my friend Debbie, the web developer. Debbie is a web developer who has spent most of her career doing JavaScript development, like front-end web development, and she just joined a mobile team that uses React Native. So she gets assigned this feature and she writes the React Native code and she gets it reviewed and everything's looking good. She tests it in like staging and the tests all pass. So she pushes it to production and then the new version gets uploaded to the App Store, the new version of this app with the new feature that she was working on. So after she uploads this new feature to the App Store, something really bad happens. There's a problem with the code and Debbie breaks the entire app. So in order to fix this, Debbie has to fix a release. She has to do a release to the App Store to deploy the fix, but she has to wait 2 weeks to do so because there's this regulation with the App Store that you can't put in a change more than every 2 weeks. So now Debbie's just like worried she's going to lose her job. She's so upset. She just started on this team. Like, what is she going to do? But then Debbie's friend John, who is also a developer on the team, suggests that they use code push and they use that to push out a new version without waiting for the App Store. So basically, code push is a tool that you can dynamically update the experience to your React Native app. So like crisis averted, they're excited now because they can just use code push and push the fix that will fix this issue, right? And then a few weeks later, Debbie is working on another feature. So that one got resolved, it's fixed, they use code push. So now fast forward to a few weeks later, Debbie's working on another feature that allows users to scan a barcode with their mobile device, and then the barcode will find a specific item for them. So this is like very common in like shopping. So Debbie's working on this feature, on this barcode feature, and unfortunately it breaks the app again. She does something and the app breaks. And Debbie is like, you know what, I'm not worried because I'm just going to use code push again with this for this error. And so Debbie and John do some digging, but they realize that they can't use code push because the bug is in the React Native code that's accessing the camera. So code push cannot be used in bugs that are for React Native code. So she really thinks like she's going to get fired and she's so upset. So they're talking about what they're going to do and how they're going to resolve this. So they can't wait 2 weeks to release a fix to the App Store because this is like a critical feature and there's a bug in it. So what do? They figure out this hacky solution in JavaScript where they temporarily disable the new feature while they're waiting for the new version to get released. And then all of a sudden, this like mysterious stranger appears and points out to Debbie and John that the thing that you just did is called a feature flag. And Debbie and John are confused. They're like, what is a feature flag? And Yoda explains that a feature flag lets you separate code deployment from feature release. And that is this sort of safety net for your feature releases. So basically with feature flags, you can turn on and off features without a lengthy release process. So Debbie's product owner or anyone on her team really can turn on features or kill features with the click of a button without having to push up any new code and without having a lengthy release process. And with feature flags, you can target your internal teammates, test your code in production, and then release it. So Debbie can add herself and John and the other team members inside of the feature flag, then keep the defaults off for the rest of the world, and then test her code in production without affecting real end users. There's all these other safety nets with controlled rollouts as well. So Yoda explains that with controlled rollouts, you can release new features gradually that ensures a really good user experience for a small group of users before releasing it to your entire user base, which is what they should have done. So Debbie's team can roll out this barcode feature to 5% of their users, make sure it works, and then if there's any other bugs, they can roll back the feature. They can also try to A/B test to see whether or not users who have that feature spend more money on the app, or they can measure performance between like iOS and Android apps. So with feature flags, you're getting this like extra layer of risk mitigation in case something goes wrong. And Yoda advises them to use controlled rollouts next time because if something does go wrong, only a small percentage of your population is going to be affected. And that's exactly what Debbie and John do. So in the future, whenever they released a feature, they used controlled rollouts to mitigate the risk in case there was a bug. So they took Yoda's advice and they started using feature flags to do controlled rollouts. And all they did is go into the feature flag configuration page. This is what it looks like in Split. And they set their targeting rules. So targeting rules define who sees a feature and who does not. So here, Debbie and John are saying that they want 5% of their users to see this new barcode feature, and the remaining 95% are going to see the existing default behavior. And then as Debbie and John's confidence increases in the barcode feature, they can slowly move this to have 100% allocation. So if they did this in the beginning and they said, I only want 5% of users to see this new barcode feature, and there was that bug, only 5% would have been affected by the bug as opposed to 100%. So now Debbie and John are really happy and they're excited because they have this new process in place for mobile controlled rollout that works really well for them. So this process is working for them and they're really excited. But then this grumpy old developer comes in. I know every team that I've ever worked on has a grumpy old developer, just someone who's been there for years and starts being really negative. So this grumpy old dev goes up to Debbie and John and says, hey, your plan only works when you have a strong network connection because you need to pull the current feature flag status from the server. But what happens when you don't have a strong connection and you can't load the feature flag configuration? Like, what do you do then? And Debbie and John are like, grumpy old developer, you don't scare us. We use caching. So because they use Split for their feature flag management, and they have this updated caching feature, they cache their feature flag data so that all of their mobile users will have access to whatever personalized experience that you intend for them wherever they are, regardless of their data connection. And Debbie draws out this diagram and talks Grumpy Dev through it. So basically, they need a way to get the feature flag configuration from the feature flag system to the phone. And then if there's no connection and you can't connect to the feature flagging system, then you look at the cache. And by automatically caching feature flags and pulling updates for those flags every 15 minutes, your newest changes are going to be reflected to your users. And then what's great about this is it doesn't matter what kind of connectivity they have when they run your app, because the data is going to refresh every 15 minutes. And there's also no human intervention needed or no extra code needed. So again, this is really good for connectivity issues. So Android caching and iOS caching allows flags that control exposure to your new features, improvements, and bug fixes to be regularly updated and stored in the cache for instances where connectivity might not be available. So again, by caching your app data locally on each device, you allow your end user to have access to its functionality even when they don't have internet access. And so this is really good for users who travel internationally or are otherwise frequently outside of their data service area. It also speeds up load time in areas where connectivity is limited, as the app can load from the cache while awaiting updates from a slower moving data connection. And then grumpy old Deb says, fine, you got me there. But won't Apple reject your app if you keep making changes more frequently than 2 weeks, because it's against App Store regulations? Like, you have to wait every 2 weeks. Like, why? How can you keep making updates? And then Debbie and John smirk and they're like, you know what? Uber has thousands of feature flags in their iOS code base. So if Uber can do it, so can we. No, in all seriousness, a lot of apps use this technique. There's an academic paper on it that Uber published about feature flagging in iOS. It's completely legitimate, and many companies are using this. So they've defeated grumpy old dev, and they continue to use mobile-controlled rollouts. Okay, so let's talk about React Native and how this is done in the code. So you might be wondering, like, how did Debbie do it? How do they use feature flags for real in React Native? So basically what happens is when Debbie renders the component that's tied to the feature, she adds this split treatments component that you import from the JavaScript SDK. And then you return the treatment based on the name's prop value passed to it. So the treatment is what differentiates the people who see your feature and the people who don't. So the treatment here would be, see the barcode feature, and for treatment off, the users would not see the barcode feature. So here, the name is enable barcode shopping, and this is the prop value that's passed to split treatment. So basically, all she does is wrap the feature with split treatments, and then the code inside of that is going to know whether the feature, show barcode experience, or whatever feature you're implementing, is on or off for the current user. So if it's on, then they're able to see the barcode, and if it's off, then they do not get this barcode experience. So this is really great because you can use feature flags in different ways. You can use it, again, for a controlled rollout and slowly, incrementally roll out your changes. You can use it to test your code in production and target only a specific amount of internal users, test with them, and then release. You can run experiments and have different groups of users having different experiences and see how it affects your metrics and your KPIs. So this is a really powerful tool that I really think developers are not taking enough advantage of. And I think I just might have talked really fast because I just got through everything, but I'm happy to answer questions or comments. I'd love to get feedback on you if you've used feature flags or if you've done a canary release or controlled rollout before. But yeah, thank you for listening, everybody.
Hello. That was an amazing talk.
Thank you.
And we have some questions. Yes. So the first question is, does this approach work for both Android and iOS?
Yes, it works for both Android and iOS. And there's documentation on this on our split page. So if you go to split.io, you'll see all the documentation there too.
Cool. Do we have any more questions? I guess no, but if you have any questions, Talia would be there. She's there for some more time, but you can just ping her on Hopin or maybe connect to her on Twitter, and you can definitely ask questions. Let's wait for some time. No? Okay. I don't think we have questions. But yes, please feel free to connect to her if you have any. And thank you so much, Talia. That was really an amazing talk.
Thank you. Thank you for having me.
Thank you. Okay, we have one question.
Sure.
So before you go, we have one.
Could you explain how you target specific users for features and not only a percentage of random users? So basically with Split's configuration, you can segment your user base. So either you can say, I want a percentage of random users, or you can target specific users in the UI. And the way you do it is you just list them out from the UI. Like we did all the backend stuff for you. So in the front end, you just say, user 1, user 2, user 3 can see the feature and everyone else will not be able to. It's all done for you.
Cool. Any more questions, Yulia? I guess no. Okay. Yes. Okay. One more. We have one more.
Does it require more testing for each feature scenario? You mean like if the feature flag is on or off? Yes. So you would have to test if the flag is on or off, but you do gain that confidence knowing that your feature flag works in both cases. So it is just one more test, but it gives you so much more value. So it is a little more testing, but I used to be a test engineer and I loved it. So I don't mind.
Okay. Thank you so much, Talia.
Thank you.
Thank you.